Exothermic welding is a process used to create a permanent, high-quality electrical connection. It's often employed in grounding systems where reliability and longevity are critical. The fundamental principle behind exothermic welding involves a chemical reaction that produces intense heat, melting the conductors being joined and creating a homogeneous, fused connection. This process offers several advantages over mechanical connections, including superior conductivity, resistance to corrosion, and long-term stability. When selecting an exothermic welding kit, several factors should be considered. Firstly, the size and type of conductors to be joined must be determined. Different kits are designed for specific wire gauges and materials. Secondly, the application environment should be evaluated. For example, if the connection will be buried or exposed to harsh conditions, a kit with appropriate corrosion resistance should be selected. Thirdly, the manufacturer's instructions should be carefully followed to ensure a proper and safe weld. BURNDY is a well-regarded manufacturer of exothermic welding equipment and materials. They offer a wide range of kits suitable for various grounding applications. Other reputable brands include Airco and Cadweld. These brands are known for their quality, reliability, and comprehensive support. When making grounding cable connections, it's important to understand the role of building steel in the grounding system. In many cases, building steel can serve as a supplementary grounding electrode, providing an additional path for fault current to flow back to the source. However, it's not always necessary to connect grounding cables directly to building steel. Whether or not such a connection is required depends on several factors, including the size and type of the building, the nature of the electrical system, and applicable codes and standards such as the National Electrical Code, or NEC. According to the NEC, the building steel must be intentionally connected to the grounding electrode system if it meets certain criteria. For example, if the building steel is structurally interconnected and forms a continuous conductive path to ground, it should be bonded to the grounding electrode system. This bonding ensures that the building steel is at the same potential as the grounding system, minimizing the risk of ground faults and electric shock hazards. The NEC outlines specific requirements for grounding and bonding in Article 250. It's essential to consult this article and any other applicable local codes to determine the appropriate grounding practices for a given installation. The NEC specifies that grounding electrodes must be connected together to form a grounding electrode system. Common grounding electrodes include ground rods, ground rings, metal underground water pipes, and the building steel itself, if properly connected. The connection to building steel should be made with a listed connector suitable for direct burial, if applicable, and should be sized according to the grounding electrode conductor requirements in the NEC. When connecting to building steel, it's important to ensure that the connection is mechanically sound and electrically conductive. The surface of the steel should be cleaned to remove any rust, paint, or other contaminants that could impede the flow of current. A listed grounding connector should be used to make the connection, and the connector should be properly tightened to ensure a secure bond. Exothermic welding can be used to connect grounding cables to building steel, providing a permanent, low-resistance connection. The exothermic weld creates a molecular bond between the cable and the steel, resulting in a connection that is highly resistant to corrosion and vibration. However, exothermic welding requires specialized equipment and training, so it's important to use qualified personnel to perform the work. In situations where exothermic welding is not feasible, mechanical connectors can be used to connect grounding cables to building steel. These connectors should be listed for grounding and bonding purposes and should be installed according to the manufacturer's instructions. It's important to periodically inspect grounding connections to ensure that they are still in good condition. Over time, connections can become loose or corroded, which can compromise the effectiveness of the grounding system. If any problems are found, they should be corrected promptly to maintain the integrity of the grounding system. To summarize, exothermic welding is a reliable method for creating grounding cable connections, particularly when connecting to building steel. The decision to connect to building steel should be based on a careful evaluation of the building's electrical system, applicable codes and standards, and the advice of a qualified electrical professional. Always prioritize safety and ensure that all grounding connections are made in accordance with best practices. When selecting exothermic welding materials, it's important to consider the specific application requirements. For example, if the connection will be exposed to moisture or corrosive chemicals, a kit with enhanced corrosion resistance should be chosen. Some kits are specifically designed for use with stainless steel or other specialty metals. The size of the welding charge should also be selected based on the size of the conductors being joined. Using too small of a charge can result in a weak or incomplete weld, while using too large of a charge can damage the conductors. Exothermic welding requires the use of specialized equipment, including a mold, a crucible, and a flint igniter. The mold is used to contain the molten metal during the welding process, while the crucible is used to hold the welding charge. The flint igniter is used to ignite the charge, initiating the exothermic reaction. Before performing an exothermic weld, it's important to thoroughly clean the conductors to be joined. Any dirt, grease, or corrosion can interfere with the welding process and result in a poor connection. A wire brush or abrasive cloth can be used to clean the conductors. The mold should also be cleaned and dried before use. Any moisture in the mold can cause the molten metal to splatter, creating a safety hazard. Once the conductors and mold are prepared, the welding charge can be placed in the crucible. The charge should be carefully measured to ensure that it is the correct size for the conductors being joined. The igniter should then be inserted into the crucible and the charge should be ignited. The exothermic reaction will produce intense heat, melting the conductors and creating a fused connection. After the weld has cooled, the mold can be removed. The connection should be inspected to ensure that it is sound and free of defects. Any excess metal should be removed with a file or grinder. Exothermic welding is a safe and effective method for creating grounding cable connections, but it's important to follow proper safety precautions. Wear appropriate personal protective equipment, including safety glasses, gloves, and a face shield. Work in a well-ventilated area to avoid inhaling fumes. Keep flammable materials away from the welding area. And never attempt to perform an exothermic weld without proper training. Grounding and bonding are essential for electrical safety. A properly grounded electrical system provides a low impedance path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock hazards. Bonding is the process of connecting all metallic parts of an electrical system together to create an equipotential plane. This helps to minimize the risk of voltage differences between different parts of the system, which can also cause electrical shock hazards. The NEC provides detailed requirements for grounding and bonding in Article 250. It's important to consult this article and any other applicable local codes to ensure that your electrical system is properly grounded and bonded. In addition to grounding and bonding, other electrical safety measures should be taken to protect against electrical shock hazards. These measures include using ground fault circuit interrupters, or GFCIs, in wet locations, installing surge protection devices, or SPDs, to protect against voltage surges, and performing regular electrical inspections to identify and correct any potential hazards. Electrical safety is everyone's responsibility. By following proper safety precautions and adhering to applicable codes and standards, we can help to prevent electrical accidents and save lives. When making grounding cable connections, it's important to use the correct type of connector for the application. There are a variety of different types of connectors available, including compression connectors, mechanical connectors, and exothermic welding connectors. Compression connectors are typically used for connecting grounding cables to equipment or enclosures. They are installed using a special crimping tool that compresses the connector onto the cable, creating a secure connection. Mechanical connectors are typically used for connecting grounding cables to grounding rods or other grounding electrodes. They are installed using a wrench or screwdriver to tighten the connector onto the cable and electrode. Exothermic welding connectors are typically used for creating permanent low-resistance connections between grounding cables. They are installed using an exothermic welding process that melts the cable and connector together, creating a fused connection. The choice of connector depends on the specific application and the requirements of the electrical system. It's important to select a connector that is listed for grounding and bonding purposes and that is compatible with the size and type of cable being used. The NEC provides guidance on the selection and installation of grounding and bonding connectors in Article 250. It's important to consult this article and any other applicable local codes to ensure that the correct connectors are used and that they are installed properly. In addition to selecting the correct connectors, it's also important to install them properly. Grounding and bonding connectors should be installed according to the manufacturer's instructions. The conductors should be cleaned and prepared properly before the connector is installed. The connector should be tightened to the correct torque to ensure a secure connection, and the connection should be inspected to ensure that it is free of defects. Improperly installed grounding and bonding connectors can compromise the effectiveness of the grounding system and create electrical shock hazards. It's important to take the time to install these connectors properly to ensure the safety of the electrical system. Grounding electrode conductors, or GECs, are used to connect the grounding electrode to the electrical system. The size of the GEC is determined by the size of the service entrance conductors. The NEC provides tables that specify the minimum size of the GEC based on the size of the service entrance conductors. The GEC should be made of copper or other corrosion-resistant material. It should be installed in a protected location, such as a conduit or raceway, and it should be connected to the grounding electrode using a listed connector. The GEC should be continuous and unbroken from the service equipment to the grounding electrode. Splices are not permitted in the GEC. If the GEC is damaged or broken, it should be replaced with a new conductor that is the correct size and material. The grounding electrode system should be inspected regularly to ensure that it is in good condition. The grounding electrode should be checked for corrosion and damage. The connections between the GEC and the grounding electrode should be checked for tightness and corrosion, and the GEC itself should be checked for damage or deterioration. Any problems with the grounding electrode system should be corrected promptly to maintain the effectiveness of the grounding system. Surge protection devices, or SPDs, are used to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, utility switching, or other electrical disturbances. SPD work by diverting the surge current to ground, preventing it from damaging sensitive electronic equipment. SPD are typically installed at the service entrance of a building as well as at individual pieces of equipment. They are available in a variety of different types and sizes depending on the level of protection required. The NEC requires the installation of SPD in certain applications, such as dwelling units and critical facilities. It's important to consult the NEC and any other applicable local codes to determine whether SPD are required in a particular application. In addition to SPD, other surge protection measures can be taken to protect electrical equipment from voltage surges. These measures include using surge-protected power strips, installing lightning rods, and grounding all metal parts of the electrical system. Surge protection is an important part of electrical safety. By taking appropriate surge protection measures, we can help to protect our electrical equipment from damage and prevent electrical fires. Ground fault circuit interrupters, or GFCIs, are used to protect people from electrical shock hazards. GFCIs work by monitoring the current flowing through a circuit. If the current flowing into the circuit differs from the current flowing out of the circuit by more than a few milliamps, the GFCI will trip, interrupting the circuit and preventing electrical shock. GFCIs are required in wet locations such as bathrooms, kitchens, and outdoor areas. They are also required in certain other locations such as construction sites and healthcare facilities. GFCIs are available in a variety of different types, including receptacle GFCIs, circuit breaker GFCIs, and portable GFCIs. Receptacle GFCIs are installed in place of standard electrical receptacles. Circuit breaker GFCIs are installed in the electrical panel. Portable GFCIs can be plugged into any standard electrical receptacle. The NEC provides detailed requirements for GFCIs in Article 210. It's important to consult this article and any other applicable local codes to ensure that GFCIs are installed in the correct locations and that they are functioning properly. In addition to GFCIs, other electrical safety measures can be taken to protect people from electrical shock hazards. These measures include using properly insulated tools and equipment, wearing rubber gloves and boots when working with electricity, and avoiding contact with water while working with electricity. Electrical safety is everyone's responsibility. By following proper safety precautions and adhering to applicable codes and standards, we can help to prevent electrical accidents and save lives.